All right, end of the day on Thursday. Do some more math. Do it till I hear that teacher bell, and I am gone. 23. You're supposed to do this with a quadratic formula. Don't sit there and think you can use a zero product property because you can't. Don't be that kid. Not set equal to zero. Can't use a zero product property unless you have the product of two things that are equal to zero. But you can distribute your 4x. That'll give you a 4x squared plus a 28x. And while you're at it, you may as well move that 7 over, because if you're watching this, you probably know to do that because you're probably an honors kid. That doesn't factor. I was just checking it real quick. You could complete the square if you wanted to. I wouldn't count off if you did. I actually prefer to complete the square. It's quicker, believe it or not. The complete the square technique is actually way quicker than the quadratic formula. But anyways, we're going to go with opposite b. B's 28. That's kind of big. So negative 28 plus or minus square root 28 squared minus 4 times 4 times a negative 7, sitting over twice a 28. I'd love to tell you I know what 28 squared is. I don't. I should, but I don't. I think I know what it is, but I don't want to be wrong. I was actually right. Cool. 784. Oh, anyways, I don't even know why I'm messing with that. I got a TI-84 in front of me. Just type the whole blasted thing in. 28 squared minus 4 times negative 7. Nope, you can't see what I'm doing here. You may not know how to type in. 896 is what's in that radical. Okay? So negative 28 plus or minus the root of 896, both pieces sitting over twice a 28, which should be 56. I don't think that you can take the square root of 896. I don't believe you can. You can't. It's something that's irrational. But let's see if it's divisible by anything. Let's try 16. 16 is something I just like to start with. It was. Okay. So it turns out it's 16 times 56. Factors of 56, however, 9, right? No, not 9. What's wrong with me? 56 is divisible by 4. So it turns out that 16 times 4 times 14 is 896. And it turns out that 16 times 4 is 64. So I'm going to reduce this thing down to 64 root 14. I'm going to go ahead and start doing my break apart too. Negative 28, 56 plus or minus the root of 64 14s sitting over 56. And I can go ahead and start my simplification process. Negative 28 over 56 is a negative 1/2, plus or minus. The root of 64 would be 8. 8 over 56 reduces down to what? 1/7? You know, I know some of you guys are pretty bad at this, but you have it. If you don't have a TI-84, get a TI-84, obviously. Math, answer frac. 1 and 7. Okay? So root 14 over 7. If I had more room, I'd write both answers. I would write both distinct answers. Now, on 24, I tell you to do this. It says shift everything right to make a positive if you want. I'm going to, because I want to, because that's how I think. So now when I do the quadratic formula, A is positive, B is positive, the world just gets better. Opposite B would be negative 8, plus or minus the square root. 8 squared minus 4 times A, which is 3, times C, which is negative 16, all sitting pretty over 2 times 3. We're going to have a positive number inside our radical. I don't know if you can hear it, but Mr. Needham is apparently leading the cheerleaders in a cheer right now. 256. Hey, that's nice. 256 has a square root, 16. So this one is actually something that would have factored. We have negative 8 plus or minus 16, both pieces over 6. That's what we have, okay? Since these are whole numbers, I will actually not break apart the fraction until the end. If I do negative 8 plus 16, I'll actually get 8. If I do negative 8 minus 16, I'll actually get negative 22. 8/6 would be 4/3. Negative 22/6 is negative 11/3. I don't know if you guys notice, but I do that a lot. I actually leave something semi-done and I come back to it and I know it immediately. I'm very tired, so I didn't even want to look at 8/6 and think about how it's simplified. So I move on, and at the same time I'm doing this. It's just something I've learned to do when I'm tired. I keep multitasking, but I'm always working on something else. Also why I make some mistakes, because I'm usually doing other steps at the same time. All right, you are supposed to determine the type and number of roots using the discriminant. Tell how many times the graph of the function will cross the x-axis, then solve using the quadratic formula. Oh, wow. So I'm asking more of you. First, figure out the discriminant. So we're going to plug into b squared minus 4ac, right? Plug into b squared minus 4ac, we would have 4 squared, because of that 4. Take away 4 times a, which is 4, times c, which is 1. And this would be 0. All right. If it's 0, it touches the x-axis once. So when I do the quadratic formula, I expect one answer. And I'm not even going to do the entire quadratic formula. I'm not. Because I've already done most of it, haven't I? Opposite b plus or minus square root of b squared minus 4ac. And there's a 0 in there, because I already did that part, over twice a, 2 times 4. Well, this is going to be negative 4 over 8, which is negative 1/2. And there's my x value. X is negative 1/2. The y value, by the way, is 0. 26. See what happens here. Shift left would be what I would do. You do you. I'll do me. Start talking about my discriminant. I'd have a 3 squared minus 4 times 5 times 2. This is going to be negative, so the quadratic formula is going to be a little uglier when everything's said and done. That is 9 minus 40, right? I believe so. 9 minus 40 being negative 31. We never touch the x-axis. These are non-real solutions. We never cross the x-axis. Just never, ever, ever happens. So anyways, time to do the quadratic formula. And like I said, you've already done the bulk of the work. Opposite b would be 3 plus or minus the root of negative 31 over twice of 5. Twice of 5 is 10, so 3/10 plus or minus the imaginary root of 31 over 10. There's your two answers. It actually pays. There are a lot of teachers that actually teach do b squared minus 4ac first off to the side. It's a fairly common teaching technique. I've never adopted it because I wasn't taught that way when I was taught. But there are a lot of teachers who always have their kids figure out the discriminant first, and then they just throw it into the quadratic formula. It's actually not a bad way to do it. It's really not. I've never found myself doing it because, like I said, I wasn't taught that way. So a principal at a high school was planning a concert to raise money for the music program. I could see Coach K doing this, right? First off, it's music. He determines the profit P from ticket sales depends upon the price T of a ticket according to the equation P is negative 200T squared plus 3600T minus 6400. Coach K learned this once upon a time. He's actually pretty good at math, but nowadays I don't think so. All amounts are in dollars. If the goal is to raise $8,500, what is the smallest amount the school should charge for a ticket to the concert? Okay? So the gist of this lies behind what the graph would look like. This is a very rough graph, okay? Very rough graph. A rough graph, this thing would cross the y-axis all the way at negative 6,400. It probably rises pretty quick. It's got an initial slope of 200. It's going to rise really quick. And then it's going to fall, okay? This axis right here would actually be price P. Oh, sorry, price is T. I don't know why it's called T. And P is profit. So this would be my profit. The goal is to raise $8,500 in profit. So I'm going to draw in this dashed line. And it represents profit equal to 8,500, or y equals 8,500, okay? I want to know what the least amount you could charge is. I want to know this intersection. But anyways, you actually didn't have to know the graph or think about the graph to do this. You had to realize what had to be replaced with 8,500. The reason I did that was to give you a visual aspect, because your best test takers and the people who get the content actually understand the underlying visual aspects of a problem. I'm going to replace that P with 8,500. And that's what I have. And now I'm going to set it equal to 0. I'm going to shift everything left. You do you. I'm going to do me. Everything's going left. 200t squared minus 3600t. I'm going to have to add 6,400 to 8,500. And I'm going to get what? 14,900? Is that right? 14,900? 8 and 6 makes 14, yeah, 14,900. That should probably be checked by me right now, because I have been up since 4 a.m. 8,500 plus 6,400. 14,900, good. 0 on the right. Now, how do you want to do this problem? For one, you want to make the numbers smaller. I don't think you can divide everything by 200, but I know you can divide everything by 100. So we're going to pull out 100, or divide by 100. It doesn't matter really how you think about it. That makes that a 2t squared minus 36t. Plus, if I divide it by 100, 149. I don't know why, but I think this thing factors. So I'm going to try to factor. I just have a hunch. Okay. It's been several years since I've done this problem, but I have a hunch that I created it to be a factoring problem. All right, so a 2t and a t. Factors of 149. I guess I'm probably wrong about this. I don't think it's actually divisible by anything. I really thought this thing factored. I don't know. I'm just over here typing in random numbers in a calculator that I know better than. No, never mind. Nope. Watch me get 2 reasonable answers from this. I'm almost certain it factors. I really am. I just can't think of what they are. Well, I've probably wasted enough time of your life sitting here contemplating what it is. So since I don't know how it factors, I'll just complete the square. Yeah, let's complete the square. So I shifted negative 149 over. I'm going to divide by 2. Why is Mr. Milbrath completing the square? Because I actually enjoy it. See, I already know how it's going to factor. It's going to factor as t minus 9. Okay, that's how it's going to happen. I'm going to take half of 18, that's negative 9. I'm going to square it and get 81. So I have to add 81 to both sides, even there. So it's t minus 9 squared. Negative 149 halves plus 81 would be 162. 23 halves? No, 13 halves. Yeah, this thing did not factor. I'm going to check myself too. It has been a very long day. So negative 149 halves plus 81 back as a frac, 13 halves. The opposite of squaring is square rooting. And I'll have t minus 9 equals plus or minus the root of 13 over 2, which has to be looked at. This is actually a good thing to go over with y'all. To clean up root 13 over root 2, you multiply the top and bottom by root 2. So that's going to be root 26 over 2. I'm just really bummed that this thing didn't come out nice. I really expected it to. So anyways, I got root 26 over 2. So I'll have t as 9 plus or minus root 26 over 2. Now back to the context of this question. What is the least? It said what is the smallest amount? The smallest is 9 take away root 26 over 2. So let's go ahead and type that in a calculator. This is a real world problem, and you should approximate this to the nearest penny. It's money, okay? Looks like $6.45. Roughly 645. There we go. There's that one as hard as I can make it. I'm sure Coach K does this kind of math for the music department. He actually does love the school, so he probably would if he was asked. Actually, he would probably be asked about it, and then he'd come to me, and I'd be like, I ain't got time for this, Coach K. Let's go with $6. All right, there you go. Hope you enjoyed the vid. Subscribe. 972 subscribers, and I can start getting paid for this.